So let me start things off by thanking Martin to accept our invitation to give a presentation on the FlexiBLAS library that he has been working on for quite a couple of years already. I'll let him do the introduction on what FlexiBLAS is. So Martin works at the Max Planck Institute and is the main author of FlexiBLAS wrapper library. So go ahead, Martin.
Yeah, thanks for the invitation and giving me the possibility to present something about our software library in your community. So first of all, let's give a short introduction of myself, because so when I see the list on participants, there's nobody I know, so I think on vice versa, it's the same. So I was doing my diploma in mathematics now, nearly 10, 11 years ago at the Technical University in Chemnitz, so in Eastern Germany. Then I'm working as an HPC administrator since 2011 and at the Max Planck Institute in Magdeburg. So mostly administrator, partly researcher. So until now I had to take care about 2 cluster machines. One was the first one with some Westmere Magni core system. So now we have one with more than 100 nodes on Skylake basis. We have several different strange machines with Power 8, Power 9 CPUs, with GPU acceleration. I think there's one Xeon Phi still around and all strange stuff. I'm trying to get my colleagues to do continuous integration for their scientific software, so I'm trying to provide environments for this. In my research, mostly efficient algorithms are for generalized matrix equations or generalized eigenvalue problems, and I develop all my software mostly with respect to getting production-ready stuff from my research or developing tools, whatever helps me in my everyday workflow at work. So that's mostly what I'm doing. So cancel. So now, yeah, that was the reason why we had to do this. So yeah, on a short announcement, I handed in my PhD thesis, and hopefully mid of spring there would be the defense, so I don't have time to give any other talks. So I'm the co-author of several software packages. So most of all FlexiBLAS, then the matrix equation sparse solver package. That's a sparse matrix equation solver. I think it will be integrated in one of the next versions of MATLAB. So then there's UF-GET library. That's an SQLite database access tool for the UF sparse matrix collection. So for those who are dealing with linear sparse algebra stuff, you can easily access and run your examples on all the matrices available there, just selecting them in an SQLite way. And I'm, together with a colleague, the maintainer of the QR update ng package. That's a maintenance fork of this QR update package. It happened because we are not longer satisfied with the maintenance of this code, and we found some bugs, and nobody responded, and so we started off ourselves. And if you search for me, I'm not so active on social media stuff. Mostly you'll find me on GitHub with this Crusader Dragon name. So the remaining guys of our team are, first of all, Jens Sarg. He is mostly responsible for testing, has some ideas. And when we started up with this problem, he was very annoyed about recompiling all this overall Gentoo system again every time he tried to explore a new BLAS library on a system-wide basis. Then Christian Himper, he was also involved in the development and the testing and ideas and the documentation. And he was joining us when he was on the way searching the fastest software stack for his Octave installation. And he's mostly announcing our new releases on his Twitter channel. Then we had for many years a student assistant, Jon Papenbrock. He did some of the coding works, some special details about doing strange profiling stuff in there. And of course, myself, I'm involved as well. And so what are we dealing about? I think most of the people here around know what BLAS is. So it's this basic linear Algebra Subprograms package. So it's more or less, it's a mixture between a reference software implementation for some linear algebra operations, and on the other hand, let's say a standard how the AP calls look like. So most of them can be categorized in these 3 levels. So it's all around, you can deal with vectors, with matrices and vectors, and with matrix stuff. So adding vectors, computing norms, computing matrix vector products, computing matrix products, rank K updates. So it's all the really basic building blocks of all linear algebra stuff. LAPACK is then the first package which directly is built on top of this algorithms, and yeah, it plays a role in many software packages. So Octave is using it, MATLAB is using it. I think nearly every FAM software is using it. So all simulation stuff. And I think there's even a cross-dependency when you install the GNU image manipulation program with some special plugins. I think there's one as well. So yeah, the typical stuff, this NETLIB implementation, that's the one which gives the reference, who's built on top of the stuff they published between end of the 1970s and end of the 1980s. That's the reference implementation and defines the AP. Then there's the OpenBLAS library, formerly known as GotoBLAS. It's an assembly-tuned stuff. Then there was this Atlas framework. It's something to automatically tune all the stuff. I think it's no longer on a really active development, but it was the standard BLAS library used for many years. Then the rather new one, the BLIS library. It's some BLAS-like stuff, but they also provide the same interfaces as the NETLIB stuff. And also there are a set of hardware vendor implementations, mostly done by Intel, by IBM, by Apple. The ARM crowd has this ARM performance libraries. AMD has this MAF kernel MAF library, but it's still now discontinued. I think they're only now contributing to BLIS. But there's the question, why do we need just another BLAS library? So typically there should be something for everybody in this list. And yeah, it started in 2013, I think, with a problem where we started compiling our code. So for example, the CMAS library, and we try to debug something. And in general, the final applications somehow depend on BLAS, LAPACK, libumfpack is a sparse matrix solver, librpack, that's a sparse eigenvalue solver. And those 3 libraries are directly depend on libblas as well. Normally they have this in their DSO, this connected dependency inside. And I link this application with this line, like you normally would do it. So when you take a look on it, everything works fine. Every library is included, what we want. Nothing strange inside. So I was working on a Debian or Ubuntu-based system. So all system inside libraries like LAPACK, UMFpack, librpack are depending on BLAS managed by the Update Alternative Framework. Yeah, okay. Then I start trying, okay, just a quick test with another BLAS library. Let's see how it behaves with OpenBLAS. I only changed the linking line, added OpenBLAS instead of the standard BLAS library. And that leads to a simple resolution conflict. So normally I thought, okay, the application was running, and then I was in segfault. I started GDB, and I was seeing, okay, I linked OpenBLAS, but the symbol which got resolved has its origin in Atlas. What happened? Yeah, a close look to LDD shows up the problem. So we mixed in 2 libraries, and yeah, we searched for a solution for this problem. So that was the point where we were coming from. And then we take a look around what's on the, let's say, on the market, what are people using for this problem. And the first one was, okay, move everything in you need with this LD preload and the LD library path. But it was not possible with this multi-file implementations like the MKL or the early Atlas versions. Then, yeah, some people proposed, yeah, use static libraries. So you don't have this stuff with the dependencies inside the libraries. Yeah, it ends up you have to track the library dependencies yourself. It's complicated linking, mostly painful in large projects when you have more than, let's say, 2, 3, 4 libraries you are depending on. Was also not a possibility for us. Then, yeah, as I said, I'm using Debian or Ubuntu mostly. Yeah, update alternatives is a good framework, but it requires super user privileges, and that's something you don't want to give to your users. And there are some restrictions with this multi-lib implementations, similar to the one you have with LD library path and LD preload. For example, if you install the libmkl stuff, which is provided by the Ubuntu guys, they ask you if you want to do to use libmkl-rt as one of these BLAS providers, and this library is super dangerous because all of the other MKL or ways how to link MKL are not possible with update alternatives directly. Yeah, other systems like Gentoo or they dealing with this eSelect or package config system, same problem again. It requires super user privileges and it's at compile time only. So when you think of you have large projects on your computer like Octave and so on, only trying OpenBLAS with another threading, so for example, OpenMP instead of pthreads, yeah, it recompiles everything again. And then so the BSD world has a problem, yeah, if they link against libblas, if it's not installed, then they choose the one the maintainer likes. So I think when you install Octave, you have the OpenBLAS on it. If you install something else, you have the reference BLAS on it. So it's quite not directly visible which one you are using. Then we had encountered some other issues, and there was this transition between this G-Fortran style and this GNU Fortran 77 or Intel style interface. So with the way they return the complex values and the Intel calling style and the Intel AB says, okay, complex return parameter has to add it as a new first function parameter, and they return a pointer there. In BLAS, it's only 4 functions affected by this problem. But if you are not really sure what your BLAS library is doing and which interface they have, and you're linking the stuff against your software, that can get some trouble. Then we encountered that there are some missing routines. For example, some component-wise absolute values. So the one norm of a complex number that's not in Atlas, and old Apple Accelerate versions and AMD ACML, they seem to depend on the same trick Atlas is doing, and this library call is missing. It's not an official routine from the BLAS, but it's provided by the reference implementation. The other really bad guy in this area is the ESSL from IBM. So they say they have a full LAPACK implementation, or yeah, you took a look at their documentation, but they only provide a few routines of them. So only the really high-end routines they provide. The other ones you can find inside the SO file, but you're not able to call them. So we have to fill up the missing ones automatically. And then there's something, yeah, new stuff happening. So there are now some extensions, for example, this alpha times a vector plus beta times a vector routine, copy routines that are not part of the official BLAS library, but in the MKL are included in MKL and OpenBLAS. So yeah, so we have to somehow deal with this compatibility issues so that we can ensure the users linking every time against the same library, and no matter what BLAS they are using in the back, they have all the routines available. Then, yeah, more or less for the guys compiling software and administrating software packages, yeah, detecting the BLAS library is also not something completely trivial. So in my beginning time as administrator, I found plenty of huge set of faulty autotool scripts. Same as with this find BLAS module from CMake. That's especially with old versions, it was horrible. Then especially scientific software of people that don't care about such tools like OpenMar, like CMake or Auto tools, you find hard-coded library paths, non-standard library locations. So in the end, we end up with something, only one path, one library to link, and that's the way which we go to get to this stuff. As I said, our FlexiBLAS library, which somehow wants to handle these problems, we had this initial idea in summer 2013. As I said, I was struggling around with this linking issue, so getting different BLAS implementations into one project, although I only want to have one. Then in December 2013, we have the first version ready, so only with BLAS and CBLAS in the beginning. Then over the years, we developed the second version. There we wrap all the LAPACK routines. That implies that we have an automatic code generator. And we allow the switching of the BLAS library from inside an application at runtime. And then in 2020, I got contacted by Inaki Yuka from the Fedora project. And he asked if FlexiBLAS is still under development, and it was in a time where I started preparing version 3.0. And there we added the idea to get hooks installed around BLAS code such that we can get a hand on how they are called, to get the analysis stuff in, to capture some information about how the BLAS stuff is called. And finally, in October, with a set of changes required by the integration into Fedora, we are now the default BLAS in Fedora Linux since version 33. Here we have interfaces for BLAS, CBLAS, and LAPACK. As I said, since version 2, we have an automatic code generator for the wrapper functions we have inside. We have an API interface for GNU Octave, so that you can do this switching even from inside your Octave scripts. The similar interface is available for R, and in last October, we released the last version, 3.04. And for those who are about licensing stuff, it's GPL version 3 code, but we included a linking exception similar to the one from the GCC, which allows to link even proprietary software against FlexiBLAS without doing a GPL violation. So you can use it in whatever code you want, as long as you link it, then everything is fine and you don't violate the GPL stuff. So I think that's important for people using or working mostly in the Python world and using MIT or BSD licensed software, so that don't make any trouble with your stuff with this linking exception. And now, how does this work? So how do we get to a solution to this linking issue, to this compatibility issue, and a way to switch the backends very fast? And our solution was to develop a plugin-like framework and only employing the stuff which is around in the POSIX standard. So the reason was that sticking to POSIX, that we get as portable as possible, at least in the, let's say, Linux HPC world, and to not include any assembly hacks, modifying the ELF libraries or modifying the global offset table or the PLT stuff. So it should be portable and still understandable what's happening there. And yeah, for those who are not familiar to the stuff, this DL star family, it's standardized in the POSIX 2001 standard. It includes 4 routines, one to open and close a shared object, one to search for symbols, and one error handling stuff. So it's really not that much. And yeah, so we did it, write some code, create a first plugin framework, did some tests. And there we ran into some issues. So first one is the DL Open library does not work like the normal linker. It only provides you a handle to the library and does not integrate anything at all. So we need to initialize every BLAS call separately. Good. Something which could be done. So the second thing is runtime loaded symbols cannot be resolved by linking the program. So every symbol we need afterwards for normal linking that behaves like the BLAS library has to be already be available at runtime, at compile time. And still we have this multi-file implementation issue, which I said with the MKL library or with the old Atlas ones, for example. And so that were the basic three issues we have to deal with. And yeah, the initialization was with this typical way shared objects are linked, and there one could specify a routine which has a special attribute. Or in former times, you should use this underscore init function. And that's something which is started before even the main function of a program starts. And so we can include everything we need for initialization, for opening stuff, for looking up all the symbols there without changing any code to the user. So the user don't have to call something like FlexiBLAS initialize or so. So in this way, we can get our initialization routine in without requiring the users to change their code. The same thing with the destructor routine that's executed after the main function exits. So that was the point where we include closing stuff, print profiling data, starting some analysis targets, whatever we have integrated else. So that was the first problem with the stuff. Then the case, as I said, we need all routines at compile or link time before. So we have to create wrapper functions. The wrapper work in this way. So we start with the application. It calls, for example, the dot product routine. We have a wrapper inside. This one takes a look at this backend selection. Backend means here that's the BLAS library you really want to execute. Then from there, it gets a function pointer and directly passes everything back to the backend. That could be MKL, OpenBLAS, the NETLIB reference implementation, BLIS, whatever. And if we have such a framework with wrapper libraries, it's easy to integrate something which we go, say, overloaded functions, so we call it hooks, where you can put stuff around the BLAS call, actually. So what we did with this stuff, I will give you later some examples for it. And we have done this for all BLAS and LAPACK routines. So BLAS is around 130 routines, LAPACK are 1,800 at the moment. So how does this work? Because programmers are normally lazy guys. So everything which is repeated work, when you do it more than one time, you try to automate. And so we find the perfect tool for this in this F2Py routine or interface from NumPy. And in this way, you can pass Fortran 77 and Fortran 90 function headers that creates a JSON file with all the header informations. And then we have a script which translates all this header information into a Fortran 80 compatible C functions. And that looks like this. So we have the subroutine written in Fortran. It extracts all the necessary meta information. For example, there's an integer, a double precision value, an array, an integer value, an array, and an integer again, and creates such a wrapper function out of it. And that's done for all the nearly 2,000 routines. And inside this wrapper function, we have the possibility to take a look up if there's such a hook or not. And if there's one, then this additional surrounding function is called. Then the only stuff which left over from this issue list is how we handle this multi-file implementations like MKL or older versions of Atlas. And when one take a look in the stuff the MKL installs, there's a tools folder inside, and it's a tool that calls MKL Builder. And that's a very tricky makefile which employs LD to create a surrogate library which includes all BLAS symbols and references everything correctly in this multi-file implementation of the MKL. That's called the same trick could be done with Atlas and stuff, and we have it included for the MKL stuff and also for other libraries, but you also can use the stuff set up with the MKL. So if FlexiBLAS detects at compile time that there's a BLAS library which consists of multiple SO files that somehow need to interact, then it can place such a surrogate library which only job is to reference all the symbols from the multiple SO files. One caveat at it is never use this MKL RT. I already said in this before that this library is dangerous because that's a library which allows to change the binary interface at runtime. So for example, the width of the integers. And that's something we could not handle until now. So I have some ideas how to handle this problem, but I think the way Intel made it and doing this, having this possibility to change, for example, integer widths at runtime, it's not that good. So how it is used afterwards, somebody have installed it. It provides such a tool called FlexiBLAS, similar to this eSelect war stuff. Some of you might know from the Gen 2 system. And we're using list, you can take a look on what BLAS libraries are installed on the system. So that are mostly the ones found at compile time, but you can also add your own ones. And then you can say FlexiBLAS default and set a backend. And then that's the default BLAS library, which is used for every subsequent program you execute. Otherwise, if you want to do some quick tests, you only have to change the environment variable called FlexiBLAS. They either give a name out of this list, or you can pass every BLAS library, LAPACK library, which is contained in a single SO file there, and then it's loaded to your environment and used for all the computations afterwards. There's a bunch of config files. We have a system-wide, a user-wide, and then because I'm mostly working on systems where I have a shared home directory between many systems, I have the possibility to have a per host configuration file so that on every host where I execute my code, a different BLAS library could be loaded. For example, on AMD machines, I load a BLIS library. On Intel machines, I load the MKL. On my small desktop computer, I load, for example, the OpenBLAS. And I only have then 3 config files for the different systems. And automatically, the host one is chosen. And it helps when using and debugging software and doing some performance tests. Yeah, the code could be influenced with some environment variables. For example, you can turn or make it a bit more for verbose. You can turn off loading LAPACK stuff. So then only LAPACK is from the NETLIB reference implementation is used. For debugging purposes, sometimes good to deactivate the color output because of this terminal artifacts with the color codes and so on. You can specify different paths for the configuration file and add additional library search paths to it. So quite usual stuff. The more interesting question is it's a wrapper library, so there is some overhead, and the question is how large is this? And for this case, I tested this on my desktop computer. It's a relatively modern Core i5 system with the current Ubuntu setup. I'm normally using OpenBLAS with OpenMP support. And I measured the shortest return path you can have from a BLAS library which is successful, so which does not run into this XERBLA error message system. So the shortest successful call, and that is if you pass in inputs of size 0. So starting something for a vector of length 0 or of a matrix of dimension 0 times 0. So that's the shortest successful return path. And then I'll access this RDTSC counter. That's this clock cycle counter from the Intel CPUs. And I did an average over 100 million runs for 3 BLAS calls. And in this table, you see how long it takes until the BLAS library returns for the example code, as I said, with 0 size input for the vector addition, for the generalized matrix vector product, and for the generalized matrix product. And the difference is only between 5 and 16 clock cycles. And I think there should be some really good connection between this difference and the number of function arguments you have or you pass in. So the longer the list of function arguments gets, for example, this huge SVD stuff routines where you have around 20 to 40 input parameters, then I think the difference would be around 20 to 30 cycles. But when you think of what BLAS is normally doing, where the performance is coming from, it's mostly coming from this level 3 routines like GEM, and this few clock cycles over here are nothing against the computational work that's done there. Then, as I said, we have this possibility to overload functions. That's around, you can install up to 255 steps. So means you can include 255 different overloaded functions for each BLAS call. So, okay, that gets slow in the end. That's nothing somebody want to do. But for what the kind of problems did we include this? So the first thing is you can build easy profiling frameworks, like measuring runtime, counting how often the function is called, without doing this -g or PG stuff when compiling the code. We already did some experiments to dynamically offload code to accelerators, so you can check the function arguments, for example. If the matrices are large enough, then directly move them to accelerator devices like NVIDIA GPUs or the AMD GPUs. And if their matrices are not large enough, it's passed back to the BLAS library you have loaded. For some debugging purpose, I already did stuff with faulty behavior. For example, the stuff I presented down there. So by changing the result of an one norm of a vector, the summed absolute values of a vector. So I included it to see what happens if there's some extreme round of errors. So that's something you can include. The overall stuff, as I said, could be chained. So you could set up many hooks calling each other until the final one is loaded, and this one then executes the original BLAS library. And what one can do with some tricky additional stuff that's not completely ready until now, you can call the original BLAS. You can call the original BLAS library in every case, but I want to do the stuff that you can call the NETLIB implementation in every case via a separate pointer as well. And we will later see why this could be useful for debugging purpose. And how to use the stuff. At the moment, we only provide one of these hooks for the easy profiling stuff, so cumulative runtime of each BLAS call and counting the number of each BLAS call, and you do it with this variable called FlexiBLAS hook. There you either give the SO file where the hook is inside, or selected out of a list. And that's a colon separated list. And the hooks are executed in a way you specify them in this list. So if you want to have 10 hooks loaded, you have to give you 10 SO files, and they are executed in the order you have give them there. And the hooks are not required to provide all the BLAS library calls. It's if you only want to modify one of them, you only build a hook which includes, for example, the gem operation and nothing more, and only this routine is modified. So what we have done with this stuff, with this easy profiling, we find some misuse of a BLAS function inside Octave. So for those who are a bit in numerical linear algebra, that's a short implementation of the conjugate gradient algorithm, some linear equation solver for sparse, mostly sparse systems with symmetric positive definite matrices. And it consists only of matrix vector operations. So A is a matrix, B is a vector, X is a vector as well. So we have here matrix product. Here, a scalar product with the vector itself. Here, scalar product with the vector with two vectors. Here, matrix product. Vector additions, vector scalings. So, yeah. And we plugged it into this profiling framework. And I take a look what happened there, which routines are executed. And we see the D dot, that's, as I said, the scalar product called for 1,000 times. Yeah, but I have here one scalar product. Here's one. So in the loop is going for 1,000 iterations. So at least there must be 2,000 of them. Okay, there's something missing. The vector additions here and here are nowhere. A set of matrix vector products. Okay, we have it here for 1,000 times, one here, one in the preparing, it fits. And then we have this symmetric rank K update. That's something here. It's a matrix valued stuff where you update a matrix with a symmetric matrix with a rank K update. That's something which should be not inside in CG code. So if you implement CG yourself, you will never call this routine. Why this in there? And then closer look takes it. The symmetric rank K update either computes the first or the second term. And when we now take a look what happens with counting the function or looking at the function arguments passed to the symmetric rank K update, we see it's the second case with a matrix of size 1 times 1, so it's a scalar value, and the size of this update is 1 times 1,000. And it's exactly the scalar product with the vector itself. So correct function was to compute a square 2 norm there. And that would be faster and less overhead from the side of the BLAS library. That was one bug we found. Then we ran up into trouble with OpenBLAS when I implemented some sophisticated QR algorithm. So I want to compute an orthogonal decomposition of a matrix, and I implement some high performance algorithm. And then I struggled around this DTRMV routine. It computes the matrix vector product where T is lower or upper triangular. So only half of the matrix is filled up with values, the other ones are 0. And I recognized that when I store this matrix with a leading dimension of 64, so that means the next entry in the same row is 64 elements away in memory. And I recognized if the dimension of the problem is larger than 16, I get some perturbed values. And if the dimension of this matrix is larger than 32, it gets completely wrong. So what I have done, I wrote such a hook, which on the one hand calls OpenBLAS. So I selected OpenBLAS as backend, so it calls the backend. And on the other hand, it executes the NETLIB implementation with the same input data, and then I compare the output. And that's what's coming out here there. So we have C until the fourth argument is the size argument, and that's the leading dimension argument. So we see beginning with 17, we have some error inside. With 32, the error is still there and already recognizable. And with 33 as dimension, we have a complete wrong result. So what we found afterwards with discussing with the OpenBLAS guys, there was a threading error inside and with a race condition. The bug seems to exist in more than 10 years, so nobody detected it. After 60, 70 comments in the discussion, we don't have the solution for this, but we figured out deactivating threading for this routine was at least successful. And this race condition was around in the high-level code, not in the kernels of OpenBLAS, because when we got our first Power 8 system, I could reproduce the bug. And the matrix, the normal vector addition was somehow involved in this problem as well. And if you have this possibility to directly build up something where you can compute the solution again with a well-known implementation where I know that it's hopefully error-free, then you can easily detect such bugs. I think in my career, I had 2 or 3 times this case with OpenBLAS, where with some strange input parameters, with some sizes, there was such a bug similar to this one. So that's basically what FlexiBLAS is doing. So what we have planned for the next release is we have a metadata logging hook already available, but we don't do any cool or don't build any cool tools out of it. Metadata logging means in this case, we collect all non-array arguments of all BLAS calls in an SQLite database. So you can say afterwards, how many times is for example, the matrix product called with which arguments, so the transpose flags, the dimension arguments, and even the leading dimensions. And that could be done for all LAPACK, for all BLAS routines. And with this information, we on the one hand want to develop such a correctness and accuracy checking tool. So doing this, what I presented for OpenBLAS in a larger way, so that you can directly say, okay, that were the problems the application did. There was an error in. Now do all the computations again. At least mostly it's the problem of the dimension arguments and BLAS optimization. So do the same stuff again with problems of the same size, with OpenBLAS and with reference implementation, or with MKL and the reference implementation. On the other hand, when you try to tune an application for high performance, you have mostly the problem, you're developing the BLAS library, you have some glue how to do your benchmarks, but they are mostly artificial. And so we want to use this data we collect from the application to reformulate and tune our benchmarks in a way that we can use the real problem sizes from the application and no longer with the artificial ones we thought of in developing or writing the software. Then we have the macOS X support already in testing. So the problem was that macOS is not using ELF binaries, they are using Mach binaries, and they have, as I said, we try to stick to POSIX stuff, but during linking, the linker behaves in a bit strange way. And that was the large problem there, to get all the linker sequences in the CMake scripts in a way that macOS accepts the stuff. Then we are planning to do suffix symbols. So that means to add, for example, a 64 for the 64 integer BLAS implementation. The Julia guys are doing this, but in a non-consistent way. For example, they add _64 for all routines. on a symbol level, but not on programming language level. And so you have then a problem that the way you call them from Fortran and from C diverges, for example, with the C BLAS routines, and that looks a bit strange because it ended up that you have to add an underscore and a C AP function, which completely looks strange. Then we try to do a per application BLAS selection. As I said, until now we could do it system-wide per user and per host with these configuration files. And from Inaki Yuka, so the Fedora guy, there comes this idea how to do it per application. And I'm already thinking about reading the stuff from the proc file system to get up which one is used. Then as output of this application-driven performance optimization stuff, we plan to do a per routine BLAS selection. So then when we see what the user is doing, which routines they execute, we try to check for which routine and which time problem dimensions, which BLAS library is the fastest on average. For example, could be that most, for example, matrix vector products are mostly called with small data, so that using a threaded BLAS library there causes too large overhead. On the other hand, the matrix product benefits very well from the threading. So that one use, for example, the matrix vector products from a single threaded library and the matrix products from a multi-threaded one. Then we have no LAPACK E support at the moment. So that's the C++ interface for LAPACK, which is a wrapper library that you don't have to do the stuff of the adjusting the pointers and the calling sequence between C and Fortran. And we did already some work with giving or providing a proper way to handle these two error handling routines from BLAS. It's called XRBLA and C BLAS XRBLA. The problem is that the way they are behaving and they are linked is coming from the time where static linking was quite usual. And normally I would expect something like an AP call like set error handler, and that's missing there. I already did some experiments for C BLAS, and let's see how far I'm coming with this. And I think in this autumn, up to end of the year, we will do a new release with at least some of the planned features hopefully included then. Yeah. Some early details about it were in a preprint released on the LAPACK working notes. And that was it from my side. So thank you for your attention. And further information could be found on our project website. We have a mirror on GitHub. On the GitHub mirror, will not see the huge new development stuff. So it's mostly the release mirror. But if you found an issue, write it down there. We can discuss it. And that's the stuff from my side.
Okay, great. Thank you very much, Martin. If there are any questions for the people in the Zoom, please raise your hand and we'll allow you to unmute so you can raise the question, or drop the question in the Zoom chat or in Slack. We already have a question from Thomas. So how easy is it to mix and match different backends and functions, especially in cases where there's a really, really good but not complete LAPACK library? Can we fall back on another implementation for calls which are not in the first library? So can you chain libraries after each other?
So at the moment, we realized it in a way that you have to specify a fallback library at compile time. So if you don't specify it, the latest LAPACK version is used, but you can redefine this fallback library at compile time. And it works in a way that first we load the fallback library, fill up all the symbols, and when then the desired BLAS library and the LAPACK library is loaded, all symbols that could be found there are updated.
Okay, so you're stuck to a single fallback library, but
at the moment, yes, but that's could be something we can integrate in the next version. So for me, this library was developed for some cases where I needed it, and so that was an idea which I didn't have until now. So, but a good thing to integrate.
And maybe a follow-up question from me. I don't see any others coming in. Can you also do something like this in a hook, where from all the libraries that are supported by FlexiBLAS or known by FlexiBLAS, that you implement a hook yourself, and based on some conditions, you pick which libraries is used to actually do the call?
At the moment, not. That's the stuff we want to do with the. So it's possible. You can access this AP which we have in Octave as well, where you can switch the BLAS libraries, and that's also available in the hooks as well. So,
okay. So you can actually something I had in mind when we've been comparing OpenBLAS and BLIS, for example, on different architectures, on Skylake and on Rome, and we see mixed results. So on especially on the Intel systems, we're looking at MKL as well. Their MKL is really good, and BLIS is fairly close for some stuff, but a lot behind for other stuff. Also based on whether you're doing single threaded or a couple of threads, so staying within the same NUMA domain or chiplet, or if you have lots of threads, we see big differences there as well. So I was wondering if you could have a more dynamic switching thing, where you look at how many threads you're running, which function you're running, on what platform you're running, so whether it's an AMD or an Intel, and if all of that will be possible in hooks. But it sounds like it could be.
Yeah, it's possible. So the hooks provide an initialization routine as well. So if you have some really expensive initialization phase, for example, where to recognize on which platform you're running and so on, that's something you only need to do once when the program starts, so you can place it there and already select or pre-select the BLAS libraries, which are the ones you want to switch afterwards, and then the switch of the BLAS library is done with only changing one pointer.
Okay.
So
the overhead is, even though you have additional logic, as long as you can do some of that logic at the very start, is still quite limited.
Yeah. I think it could be that we have to include one or two special routines for this case to make it more efficient. But in general, it's not too bad at the moment. But it's so as the way I implemented it, it could even get faster, and we only had to do one or two routines or include one or two routines there to get it even faster.
But for let's say for realistic small operations, so if you say, let's say a 10 by 10 matrix, and you do a matrix operation, whatever it is, how much overhead is there percentage wise? Is it like 1%? Is it 5%?
So it's still in the 1-digit area.
Okay, even for very small.
Yeah. So I think when you are going to this case 4x4, which could be realized in 5-6 CPU cycles with modern vector units, then no longer. But that's something where, so from my research and my application development, I would say calling BLAS with problems that are typically could be done on a sheet of paper by hand, that's the case where you should directly implement it in your application and not calling to BLAS, because then the overhead with preparing the function execution, like putting everything on the stack, calling the function, coming back from the function call, is even more than the computational work.
Mm-hmm. But that's not really related to FlexiBLAS. That's it.
No, that's a general problem when you're dealing with BLAS and small problems. So
yeah, you have to make sure you actually benefit from using it.
Yeah, I think when you write your code in Fortran, there is now a matmult function, and with G-Fortran you can specify the switching point when this function call should be directed to BLAS and when it should be written out by the compiler as inline stuff.
Mm-hmm. So there's a follow-up question by Yuri. So somebody still needs to prepare a landscape of architecture, routine, problem size combinations, I guess, to select the best choice on the fly. So in terms of picking a different backend based on some conditions. And he's asking if there's any concrete plans for doing this. And I'm guessing he's maybe interested in helping out. Or
yeah, so as I said, the plan is lying around in my head for a long time. That's why we already implemented this metadata logging. But for the remaining stuff, I didn't find time in the last 2 years due to trying to get my PhD thesis finished. But I think when this is done, I will take a look more inside this, because due to the huge zoo of different computers we have in our institute, I'm also interested in this problem.
Okay, so I guess people can reach out if they're interested in working on something like
so
this.
Drop me a line and we can discuss it.
Okay. There's also a question, I mentioned it to you as well, you're fully aware of it, the Julia alternative. So they have this LibBLAS trampoline thing.
Yeah, you sent it to me on, I think, Friday. Yeah, this BLAS trampoline, I take a look at how they made it. So it's a similar approach. Would get even a smaller overhead than ours, but it's not portable because they try to modify the procedure location table. And that's something I think that's very dangerous, because during the development of FlexiBLAS, we found on the PowerPC little endian platform 2 code generator bugs from GCC, which are related to the procedure location table. And I think it's still dangerous to modify, to move in stuff there. And as far as I saw their code, you need an assembly kernel for each new architecture appearing. And even for the old big endian stuff, they don't have any glue to do this at the moment.
Okay. See if there's other. Yeah, there's another question. So batched BLAS calls. So I understand there's some libraries like Plasma and Magma have support for packing operations together before actually going ahead and doing them to improve performance a bit. Is that out of scope for FlexiBLAS or?
For Plasma, I know that they map it directly to BLAS at the moment. And let's see when it's appearing in 1 or 2 of this of this efficient BLAS libraries, when they have an interface for it and it sticks to one interface where I could say that's stable, then we can integrate it. So I would not say out of scope, but it's a relatively new operation and not included in the reference one. And so we have to wait until there's a stable AP around for this type of operation.
Okay. See if there's any other questions. People who have questions, do share them in the Slack chat, for example. I think I had one more. Okay, so two questions related to installing and building FlexiBLAS. So when you're building it, you can give it a list essentially of BLAS libraries it should build against. But you can also specify stuff at runtime, at least for the single SO BLAS libraries. Is there a benefit in doing it at compile time?
So it was this one at compile time was more or less if you have somebody with a standard desktop Linux system and who want to use it, it collects all the BLAS libraries he has installed on the system and pre-configures everything. For example, so from the maintainer point, from the distribution, that's also a bit easier. But you can do it at compile time, at runtime, however you want. So, and even you can in the system-wide configuration file, there's like for many other software projects, system configuration file name .d, a directory, and all the files are in there are scanned as well. So if you have new BLAS libraries, you only place one piece of configuration file there and it's scanned. So the system administrator could add as many BLAS libraries he or she wants there to provide them to the users, even after installing it or after compiling and installing it.
But there's no additional runtime overhead compared to doing that.
No, so from the runtime point of view, there's no difference. It's only more or less configuring and make install stuff, and it does not change anything inside FlexiBLAS if you compile it only with the NETLIB reference backend, or if you compile it with NETLIB, OpenBLAS, BLIS, MKL. So from the binary point of view, there's no change inside FlexiBLAS.
Okay. But for stuff like MKL, can you also do it just at runtime? Because there you have the problem with the different SOs, right?
Yeah, there's this MKL builder tool, this thing which is normally provided by the MKL installation. There you create this wrapper library yourself, and then move this SO file to some place where it could be found, and then it works as well.
Okay.
There's
so you don't
we
have to
documented it on GitHub in an issue, and in the next release we extended documentation for this case.
Okay. And then what about the fallback to NETLIB BLAS? Because that's a bad idea from a performance point of view, at least. I understand it's interesting when you showed one of the cases where you can do comparisons and you can catch bugs or do things like this. But is it possible to disable that as well? That FlexiBLAS never falls back to NETLIB?
As I said, one can select another fallback implementation at compile time. I think it's could or should be possible at runtime as well. And this fallback is really rarely happening. So it's only for this. So for the standard BLAS calls, only this one norm of a complex number is affected, and that does not make any performance influence. And with LAPACK, for example, you load an MKL library which only has LAPACK 3.7 integrated. But FlexiBLAS is compiled with the latest LAPACK version, the 3.9 at the moment. Then there are a few symbols missing, and if you call one of these routines that are not in the MKL, it uses the LAPACK implementation out of the reference, but the BLAS calls inside this LAPACK implementation are mapped to MKL. Okay. So it's not that missing LAPACK function in the backend results in the case where you use the whole NETLIB stack. You only then use this LAPACK part, but the BLAS calls are still going to the selected backend. And that's true for mostly all of the highly optimized LAPACK routines in the vendor implementations. For example, when you take a look at OpenBLAS, they provide LAPACK, but they only improve the performance in a handful of operations. Mm-hmm. And most of the LAPACK stuff stays untouched. And I think that's also the case in MKL, because I don't think that they are adjusting this 1,800 routines, everything by hand.
Okay, yeah. So there's no, in practice, there's no problem with having NETLIB BLAS in there. It's only used as a last resort, and if it is used, it really has a performance impact.
Yeah. So normally, at least this 140 BLAS routines are provided by all implementations.
Yeah. Okay. There's another question by Sam. Is the metadata logging hook available somewhere already? So can we find that?
Not yet, but I think that could be something I can make available during the next weeks. I want to I want to move it to a separate project such that I can develop the hooks independently of FlexiBLAS, and when my student assistant wrote this thing, he directly moves it into the source tree. Nah, okay, I have to get it out there.
So I guess maybe Sam can fire you an email if he's interested in,
of course,
in playing with that. Okay, yeah. Okay. I don't see any other questions. So yeah, I guess we can wrap it up here. Thank you very much, Martin. This was very interesting. And it looks like a good fit for some of the problems we have in the EasyBuild community with indeed with switching between different BLAS libraries, and especially with AMD systems now being back in view, which make us look at other BLAS libraries. It looks very interesting. So
if you want to do more research in this way, what's the best BLAS library? That's something I'm interested as well. And so if there are routines missing, if you find something where we could accelerate the mechanisms inside FlexiBLAS, feel free to ask. And I think we will find a good solution and to integrate stuff very fast, such that we can get there to nice results.